Thank you very much. Well, once again, thank you very much for this invitation to participate in Space Habitat event. We're honored to be here. So we'd like to present to you throughout this session the advances of the Bioculture Space Garden team regarding the current research that aims to create a solution for one of the greatest challenges in the space sector, the production of food for long duration missions. Okay. Why is space exploration so important? Because it creates jobs for engineers, scientists from many disciplines, architects, law professionals, physicians, just to name a few. People coming from different fields of study and countries can take part in this upcoming revolution. And by doing so, new technologies, scientific discoveries, and advances in medicine that are useful both for space and Earth can be generated. In addition to this, new ideas related to architecture and habitats for future colonizers on Mars and of other planets, of course, will have an opportunity to become, to turn into reality, making the colonization dream possible. Okay, well, in here you can see some of the harsh characteristics of Mars atmosphere, and well, general characteristics of the planet. Which are like some reasons why humans must colonize Mars? Well, first of all, for ensuring the survival of our species. You know, we are never certain when an asteroid like the one that ended with the life of all the dinosaurs so many years ago can arrive to Earth and eliminate all life from Earth. You know, we need to have a plan B in case of a disastrous event could happen in the future. So Mars is a really good candidate for this. In addition to this, there's also discovering life on Mars. Well, Mars is an ideal target because it has a day about the same length as the Earth's, water, ice on its surface. Moreover, it's well, the best available option right now because the closest planets, for example, Venus and Mercury, are too hot, and the Moon, for example, has no atmosphere to protect potential residents from destructive meteor impacts. In addition to this, there's also improving the quality of life on Earth. For example, in Hubble's for getting better images of the Hubble Space Telescope. There were in the earlier years of the telescope really blurry images that were taken by the telescope. A new computer algorithm was created in order to get better information from those images. That algorithm was used by a physician here on Earth, and he found it the best option to detect breast cancer on X-ray images. So there's other chances to use it in applications such as medical applications, and well as growing as a species, obviously. So the need for the human colonization of Mars, its low gravity, which causes liquids like water to evaporate, and the need for the production of food for long duration missions, gave rise to the Bioculture Space Garden project, which consists of a device that will enable the growth of diverse plant species for human consumption on the planet. And the device that can be seen in this image has on the outside a heat insulating bag made of neoprene and denim that protects its surroundings from the contamination with pathogens. On the inside, it has a biodegradable bag that compacts the substrate and other components. It has little hoses, can be also seen there, and that provide the plant with different solutions it requires. And the device has also humidity and temperature sensors that form part of a monitoring system that represents a novelty when compared to other current approaches on space gardens. In addition to what has been previously mentioned, we have also developed a continuous control drawer that complements the Bioculture device with the objective of generating a safe and sustainable environment for the plant species to cultivate. It can be seen in here, in this image. It's equipped with a ventilation system, a system for the monitoring of gases, lighting in different light ranges of the electromagnetic spectrum, and walls that help the system achieve heat insulation and absorb any leaks that it may have. Okay, the initial selection of the species to be tested in the system were lettuce, potato, and corn, achieving not only the successful sowing and germination of their seeds, but also the complete development in our system. These species were selected for their high nutritional content when compared to other plants. Here we show a table regarding the nutritional content of the selected plants. And we have decided additionally to incorporate amaranth and quinoa in our tests, as they're both considered part of the superfoods category because of their unparalleled nutritional content. Okay, the fact that Mars' gravity is 1/3 of that of the Earth that makes the transport of nutrients throughout the plant to be affected. The design of the bioculture device helps the plant with this process by compacting the nutrient solutions in the internal bag. Specialized nutritive solutions have been chosen to further facilitate the transport of nutrients, the nutrient uptake by the plant, and the development of these vegetables that are being cultivated in this system. Okay. We know that on Earth, high levels of salinity and low levels of water in the soil are problematic for the growth of plants. Given that similar conditions are present in the Mars regolith, in addition to toxic chemicals such as perchlorate salts, the development of novel plant cultivation techniques, such as those achieved by the Bioculture Space Garden, are necessary. Here, sorry for the images being in Spanish. We've only put it here for illustrative purposes. There are several viruses and pests, such as caterpillars, mealybugs, aphids, and several types of worms that can cause great damage to plants. This can reach other planets if we are not careful enough to sanitize the plant material that will be taken there in rockets. So each plant has very specific nutrient requirements. If we supply them with an excess or absence of the nutrients they need, several symptoms of damage to the plant, such as chlorosis or yellow leaves, as it can be seen here, necrosis, or changes in color, like for example, changes to red, could appear. So this is something we have to be very careful on.
Okay, thanks. I don't listen in. Hello.
Yes, we can listen you.
Okay. Yeah. Well, thank you, and thank you for you welcoming me and my partner to this convention on the exploration of the Mars. Let's start it. As my partner had already mentioned, space exploration requires technology that suits the condition of the other worlds for exploration and colonization. Biocontrol is a more solution to the big challenge of exploration, but how it works. Basically, its operation is to compact everything inside the bag. The treatment given for said germination consists of different processes of the team. Is the use of liquids since they have a high level of nutrients. This leach is produced from the filtration of nutrients onto salt, and this liquid is used to reheat the salt. As you will see in the data table, we can find the main nutrients in the content. Cell-free water should also be used to note generation alteration in the plant growth, and the hormonal solution of acceleration the growth. And the benefits of using this solution is the biological regeneration of the soil science. To use of liquids increase the amount of microorganisms. The next page, please. Well, the solution used must go through some tests before they can be used for irrigations. The most important test is pH by Y. If the nutrient solution increases your pH, it can alter plant growth, nutrient transport. So continuous review of the solution is necessary. There must also be carried analysis of solution presence in the water. This can also affect the ground and transport into plants. As you can see in the images, we can observe two sensors of the pH and another TDS indicating optimal ratings of the within the ranks operation. But what happens, we don't have enough light of the plants. We need artificial light with a certain wave of colors emitted by the sun that the human eye cannot see. Here are some graphs where the light emitted by the sun is now and one needed with blue and the red forming and the purple color. In the graph on the right, we can observe the emission of the light inside the control box. Let me start it. And the next page, please. Well, this is on the graphic and the light and the color and the light. And in this graphic, and we can see and like and inside the control box and say high or level is regulate and controls on the panel as no. Well, we started. Oh, are you will we and started and the graphic, please? Well, I will continue. Hi. 20 seconds. Hi. It's very high. Very high. This is light as a regulate and the panel control and the box. Well, and yeah, next please. Well, as a conclusion, we can see the biocolchon is an insulated and safe system to allows the rapid growth of the plants in difficult environments. In the imaging, we can observe the rapid growth of the plant in the 3 days. Taking account the deprived and the sunlight and the normal growing conditions. As my partner mentioned it early, to selection species or seeds is due to its high resistance and difficult environments. In the imaging, we can observe the high iron revenue necessary for the human body. And the next page, please. Here we can see other images of the current plants growth. They were made in the left images. We can see in the in vitro growth of species, but in still lacks germination science imaging was taken a couple of days ago. In the other 2 images, we can observe germination tray where rabanus and lettuce. It's important to mention to germinate in the half in the time to was planted. In the following images, we can the next page, please. In the following imaging, we can see on the left and the right white lettuce and the normal plants on the right and below inside of the control box. This box are already mentioned as differently sensors to monitor to environment and to get an idea tells which what really happens inside in the box. The next page, please. We find a graph on the internal environment of the control box. In the orange, we can see to temperature. In the yellow to humidity, and the green we can observe to humidity in the ground. As will be seen to project already carriers great advanced focused procedures for analogous mission. Is the next, please. This project is extensive and can participate for this continuous improvement. There are several sectors where it can be used most relevant of the highest priority and the studied programs in the science part. In the agriculture sector, and can obviously we be a lack of knowledge admissions wherever the case maybe they can contact used by email for my partner or for me. In this is everything. And thank you very much for this presentation.